Today our topic is function and function notation. So our essential question is, how can I identify a function and how can I use function notation? First off, some vocabulary. We have relation, which is a mapping of an input to an output. Second, we have a function, which is a relation that relates one input to exactly one output. Domain are the input values of a function. Range are the output values of a function. The independent variable is your input variable, and your dependent variable is your output variable. Usually input is x and output is y. Alright, let's put this into practice. Identify the domain and range of a function. So remember, domain is your input values, what you put into the function. Range is your output values, what you get out. So the input-output table shows the cost of various amounts of regular unleaded gas from the same pump. Identify the domain and the range of the function. So the input is your gallons, what you're putting into the function. So that would be 10, 12, 13, and 17. So that's going to be your domain. 10, 12, 13, and 17. Those are your input values. Then your output values are dollars, how much you have to pay to get the gas, which is going to be $19.99, $23.99, $25.99, and $33.98. So I'm just going to circle these and draw an arrow to the range. Those are your output values, what you get out of your function. Next piece is identifying a function. Now a function is a one-to-one mapping. It means each input can only be mapped to one output. Alright? So to check, we have to start with the input values and make sure that they only have one output. That's how we check. So we always start with the input and we check to make sure they only have one output. So if we look at this, these are mappings, so they map your inputs to your outputs. So if we look at -3 and we look at the mapping, it goes to just one output of 3. So that one's good. That's one input to one output. Now we look at -2, goes to -6, one input to one output. -1 goes to 0. One input to one output. We're good. 0 goes to 15. One input to one output. We're good. Lastly, 1 maps to -1. Each input has only one output, which means this is a function. Now if we look at the second mapping, each input needs to go to one output to be a function. So -3 has one output, -2 has one output, -1 has one output, 0 has one output, but if we get down to 1, 1 has an output of 15 and an output of 0. 1 has 2 outputs. And that's not okay. It can only have 1. So this is not a function. Same concept over here, but with tables. So for this, an x is an input, a y is an output. So if we look, this can be tricky because we have to just make sure that all of our inputs only appear once. So 0 has one output, 1 has one output, 2 has one output, and 3 has one output. So this is a function. Now let's look at our next table. Again, x is your input values, y is your output values. If we look, 3 has one output, 4 has one output, but here 5 is listed twice. It has an output of 10 and an output of 12. That means 5 has 2 outputs. You cannot have 2 outputs in a function. You can only have 1, which means this is not a function. On the back of your notes, if you flip over, we're going to talk about function notation, so using function notation. This is an example of function notation. We say f of x. That's how you pronounce this piece right here. F of x. That piece right there, we say f of x is how you read that. So make sure when we're reading it, we read it appropriately. That is f of x. It's a function of x. Now x is going to be your input value, and then whatever it equals is what you're going to get out, your output value. So really, if we see f of x equals 3x plus 1, that's pretty similar to y equals 3x plus 1, except for we're just replacing that f of x with a y. Now, let's use function notation. So, evaluate using function notation for the function f of x equals 2x minus 10. Evaluate f of negative 2 right here. This is f of negative 2. Now, I like to just start by writing out my function. F of x equals 2x minus 10. Now, if we write f of negative 2 underneath it, x is becoming negative 2. We're inputting negative 2 into our function. It's our input value. So then for x in our function, we're going to replace it also with negative 2. We're replacing both of our x's with negative 2. So then as we solve this, we can say f of negative 2 is equal to whatever this value is, which is going to be 2 times negative 2, which is negative 4, minus 10. 2 times negative 4 minus 10, negative 4 minus 10 is negative 14. So f of negative 2 is equal to negative 14. So that means when we put negative 2 into our function, we get negative 14 out of our function. Just that one value. Again, we're going to use that same function, but now we're going to evaluate f of 7. So same concept, we write f of x equals 2x minus 10. We're still using the same function. Then we replace the x with this number, f of 7. So we're taking x and replacing it with 7. So we replace this x and this x with 7. Then we just evaluate. F of 7 is equal to 2 times 7, which is 14, minus 10. 14 minus 10 is 4. So f of 7 equals 4. So that means is when we put 7 into our function, 4 comes out of the function. So if we were to make an input-output table, x, f of x, when we put negative 2 into our function over here, we got 14 out, negative 14 out. When we put 7 into our function, we got 4 out. That's just what that means. Again, we're still using this function notation, but now we just have two more problems, number 3 and number 4. We're still using that same function, f of x equals 2x minus 10, but now it's just a little bit different. We want to find the value of x when f of x equals 6. So we want to know what is x if f of x equals 6. So if we write f of x equals 2x minus 10, this time we don't know what x is, but we do know what f of x is. We know f of x equals 6. So when we see f of x here, we can replace it with a 6 because we know it's equal to 6. So we can say 6 equals 2x minus 10. And now we're going back to last unit with solving equations. Undo minus 10 with plus 10. We get 16 equals 2x. Undo times 2 with divide by 2. We get x equals 8. So that means when we put 8 into our function, we get 6 out. So here we know if we put 8 into our function, we're going to get 6 out of our function. Last example, find the value of x when f of x equals negative 8. Again, we know f of x equals negative 8. Now we need to know what does x equal. What is our input value when our output value is negative 8? So find the value. We say f of x equals 2x minus 10. We know f of x equals negative 8, so we can replace f of x with negative 8. Solve the equation. Undo minus 10 with plus 10 on both sides. We have negative 8 plus 10 is 2 equals 2x. Undo times 2 with divide by 2. We get x equals 1, which means when we put 1 into our function, we will get negative 8 out of our function. Alright, that's all the notes I have for you today. Thank you for watching this video, and please subscribe to my YouTube channel.